हेलो एवरीवन एंड वेलकम टू दिस चैनल। तो आज हम लोग करने वाले हैं एनालॉग इलेक्ट्रॉनिक्स 1 में हमारा अगला टॉपिक दैट इज कलेक्टिव फीडबैक बायसिंग। सो यहाँ पे हमारे पास सर्किट है फॉर द कलेक्टिव फीडबैक बायसिंग एंड यहाँ पे वी आर अज्यूमिंग दैट आई करंट इज फ्लोइंग टू द रेजिस्टर आरसी। By applying KCL at this point, we can see that I is going to be equal to IC plus IB. अब first step हमारा होता है that we want to determine the value of IB current. So for that, we are going to apply KVL in the input part of the circuit. So we will have our equation as VCC minus I times RC minus IB RB minus VB is equal to 0. Now we know that IC is equal to beta times IB. तो यहाँ पे हम लोग IC को replace कर सकते हैं by beta times IB. So we will have our equation as now VCC minus beta plus 1 times RC plus RB whole times IB minus VB is equal to 0. From this we can get the value of IB, which is VCC minus VB by beta plus 1 times RC plus RB. And यहाँ से हम लोग collector current निकाल सकते हैं which is equal to beta times IB. Now second thing that we have to do is determine the value of VC. So उसके लिए we are going to apply KVL in the output part of the circuit. So our equation is going to be equal to VCC minus I times RC minus VC is equal to 0. Now we know that I is equal to IC plus IB. So we will have the equation as VC is equal to VCC minus IC plus IB times RC. And we have already taken the value of IC in the previous slide. Now let us talk about the advantages and disadvantages. तो हमारा Q point stable रहता है against the variation of temperature, against the variation of VCC and against the variation of beta. So in the case of beta, we know that IC is equal to beta times VCC minus VB by RB plus beta plus 1 times RC. Now here we are going to approximate the value of beta plus 1 to beta. So here in the denominator, हम लोग रह जाएंगे by RB plus RC times beta. Now here we are going to consider another assumption, that is beta times RC is much greater than RB. So इस case में you can see that हमारा beta beta will get cancelled and our collector current is now independent of beta. Now let us talk about the disadvantage. So जब हम लोग ये assumption लेते हैं that beta times RC is much greater than RB, so इस case में either we will have to increase the value of RC, जिसकी वजह से हमारा voltage increase करेगा and हमारी cost भी increase करेगी, और either we will have to decrease the value of RB, जिसकी वजह से हमारा reverse bias of common bias is also going to decrease. So these are the disadvantages of this particular circuit. Now let us have a look at a numerical. So figure shows a silicon transistor biased by a collective feedback method. We have to determine the operating point here. तो इस circuit पे देख के हम लोग easily identify कर सकते हैं that our VCC is going to be equal to 20 volts, RC is equal to 1 kilo ohm, RB is equal to 100 kilo ohm and beta is equal to 100. And Q point हमारा क्या होता है, that is IC, VCE. So first of all we have to determine the value of IB. So उसके लिए we are going to apply KVL in the input part of the circuit. तुम्हारी equation होगी that is VCC minus IC plus IB times 1 kilo ohm minus IB times 100 kilo ohm minus 0.7, because we have mentioned that our transistor is a silicon, equal to 0. Now we know that IC is equal to beta times IB. So from this we can get the value of IB and we have all the rest of the values. We can just put them in the formula and we will get our IB as 96 microampere. Now we have to get the value of collector current, which is equal to beta times IB. So IC is equal to 9.6 milliamperes. अब बात करें हम लोग VCE की. So for that we will have to apply KVL in the output part of the circuit. So the equation is going to be equal to 20 volt minus IC plus IB times 1 kilo ohm minus VC is equal to 0, and we just have to put the values now. From this we will get the value of VCE as 10.304 volt. Now let us have a look at the collective feedback biasing with the emitter resistance. So जो ऊपर वाला part of the circuit है, that will remain the same. We are just going to add an emitter resistance at the end. So if we apply KCL at this particular point, we can see that I is going to be equal to IC plus IB. Now first of all, we are going to determine the value of IB तो उसके लिए we are going to apply KVL in the input part of the circuit. So the equation is going to be equal to VCC minus I times RC minus IBRB minus VB minus IERE is equal to 0. Now here we know that I is equal to IC plus IB, so we can replace the value of I here. Now here we know that IE is equal to IC plus IB and IC can be written as beta times IB. So from this we get the value of IE as beta plus 1 times IB and we get the value of IC plus IB as beta plus 1 times IB. So ये दोनों हम लोग replacement करेंगे in our previous equation and we are going to get our equation as VCC minus beta plus 1 times IBRC minus IBRB minus VB minus beta plus 1 times IBRE is equal to 0. Now after rearranging the equation, we will get the value of IB as VCC minus VB by RB plus beta plus 1 times RC plus RE. If we have to get the value of IC, that is going to be equal to beta times VCC minus VB by RB plus beta plus 1 times RC plus RE. And अगर हम लोग चाहते हैं that our collector current should be independent of beta, so for that we will have to follow this particular condition, that is RB should be much less than beta plus 1 times RC plus RE. Now lastly we have to just determine the value of VC. So for that we are going to apply KVL in the output part of the circuit and we are going to get our equation as VCC minus IC plus IB times RC minus VC minus IERE is equal to 0. Now we know that IE is equal to IC plus IB, so we can replace IC plus IB as IE. After this we are going to have our equation as VCC minus IE times RC plus RE minus VC equal to 0. Now we know that IE is approximately equal to IC, so we can replace IE by IC and from here we can get the value of VC as VCC minus IC times RC plus RE. So that was all for this video and I will see you in the next one.